Let's take a look at the function f of x equals x plus 2, the quantity squared, times x minus 1, the quantity cubed. And we want to go ahead and list each real zero and its multiplicity. So remember that the zero is the same thing as our x-intercepts. And when we're taking a look at our factors, they're always going to be in the form x minus our 0. So the easy one to look at is the set of parentheses that has the x minus 1. Right? If it's in the form x minus our 0, then one of our zeros or one of our x-intercepts is going to be a 1. Multiplicity refers to how often that 0 occurs. And this multiplicity is going to come from our exponent on the factor, which is the set of parentheses. So in this case, that 0 is going to occur a total of 3 times. Right? And we know that because if we had to expand this function, this x minus 1 to the power 3 piece, we would have to write out this set of parentheses a total of 3 times. The other way we could find the 0 is by taking the set of parentheses that x minus 1, and we can set it equal to 0 and solve for x. So we could have added 1 to both sides to get the x value of 1, which is our x-intercept. So whichever way you like better. And we have a second 0 that's coming from that x plus 2. We could go ahead and set that equal to 0, subtract the 2 from both sides, and we'll get an x value of negative 2. Right, so that's our other x-intercept. And the multiplicity on this set of parentheses is a 2. Right, that set of parentheses occurs twice if we had to write it out. So there's our function in the expanded form with all those factors written out. Let's go ahead and take a look at part B. We want to determine whether the graph crosses or touches the x-axis at each of those x-intercepts. So our first 0 was the number 1. Keep in mind that it had a multiplicity of 3. So the multiplicity of 3 right there is an odd number. And anytime your multiplicity is odd, that means our function is going to cross at that 0. Or at the x-intercept. Our other x-intercept, or 0, was a negative 2. And the negative 2 had a multiplicity of 2, which is an even number. And anytime you have an even multiplicity, then your graph is going to touch the x-axis at that x-intercept. Let's go ahead and take a look at the graph over here on the right-hand side. All right, if we take a look at the 0 of negative 2, you'll see that the graph touches the x-axis right there at the negative 2, and it should because that multiplicity was even. And if we take a look at the x-intercept of 1, you're going to see that the graph crosses through that x value at 1. For part C, we want to take a look at the maximum number of turning points that we could have on our graph. And turning points are where your graph changes direction. So for example, our graph could be decreasing and then all of a sudden increasing. So here's the spot where the graph is decreasing, and then all of a sudden it changes direction and it increases. So this point would be known as a turning point on our graph. Right? And the max number of turning points that your graph could have is always going to be your degree, which is your highest exponent, minus 1. We'll come back to this part C here in a second. Let's take a look at part D. We want to determine the end behavior, or find the power function that this graph resembles. So the power function is going to refer to your leading term for your function after it was all the way multiplied out. Now, we have 5 sets of parentheses here. We don't necessarily want to multiply this all the way out, but I went ahead and wrote it in expanded form. And let's just find the first term, which is really just multiplying each of these first values times each other. Alright, so I've got x times x times x times x times x again, which is going to give me x to the 5th power. So my leading term here is going to be x to the 5th power. Obviously, if I kept multiplying that out, there would be more terms after that, but I only want the first term. That's my power function, and this graph is going to resemble a function of x to the 5th. Right, so if we go back and take a look at part C, my highest exponent in this case, or my degree, is going to be a 5. So for my turning points, I'm going to have 5 minus 1, or a max of 4 turning points. Now, that doesn't necessarily mean that our graph is going to have a total of 4 turning points, but that's the most that it could have.